Mason Company, headquartered in Charlotte, North Carolina. I work out of the Charleston, South Carolina office doing field work, sales, and support for our customers. I wanted to talk to you today about flashing. This is when the inlet pressure makes it a liquid and the downstream pressure of the process makes it a vapor. So it has to change. There's no stopping it. It's going to be liquid coming in and a vapor coming out. What that does is you have a liquid in a small form, and the vapor form of that same amount of fluid is much greater than the liquid form. So therefore, things have to move much faster, and we get a fairly violent change as it goes from liquid to that vapor formation. So there's the opportunity to have flashing damage. And flashing damage is going to look different than cavitation damage. Flashing damage is very smooth, very shiny, and will show deep cuts in some areas, but you'll see a very shiny look, a very smooth look across it, almost like it was polished by some individual beads. And that's actually what's happening, is that liquid turns to vapor, and the vapor is not 100% vapor, so there's liquid particles that do that polishing, but they have that vapor all around it, and we continue to move to a total vapor state for that process. So, as I said, you can't stop it. If it's liquid here and it's going to be vapor when it gets to this vessel, it's going to flash, and it's going to flash over where the restriction is that causes that pressure drop. So oftentimes that's a control valve that's reducing the pressure to move it and allow it to flash into the container where it's going to go to and possibly be recovered, or it's going to be flashed into a pipe and moved to another phase of the process. Flashing, like cavitation, is a lot to do with geometry in terms of how we handle it and metallurgy. It's a little bit different from the standpoint of, hey, we're just trying to minimize how much that flashing damage is going to occur on our piping and our valve. So a lot of times we'll use an angle globe valve where the flow will come in and take that 90-degree turn, but once we've gone through the restriction inside the valve, we don't want it to touch the valve body any further. We want it to just go flow straight down and go to the next size pipe. And a lot of times we're going to create a pipe increase. So we're going to swage up from whatever the outlet of the valve is very quickly to almost double the pipe size, could be more, depending on the amount of fluid that we're flashing. Sometimes we flash into a vessel, sometimes we flash into some piping, and either way we want to give that flashed material a lot of place to dissipate its energy. Even if we've got a change in geometry where we go through the valve and we get to a larger velocity, a larger pipeline where we can limit the velocity of the fluid, we need to have a straight run of pipe as long as possible. Therefore, we don't want an elbow directly downstream, because the flow is going to impinge on that elbow and not move through the piping like we want. Oftentimes, if we don't have that option, sometimes we'll put some a weld, or we'll use some different piping materials that resist flashing to provide for that turn, that part of the elbow where it needs to make a change. Oftentimes, if we're going to flash into the tank, we will take the valve and move it right in at the tank outlet or inlet, so that as the valve opens and that fluid flashes right into the tank, and then we don't have to worry about piping damage through there. Most of the time the tank is large enough that we're not going to shoot that high velocity jet across to the other side. It'll all dissipate within the tank itself. So to kind of wrap up this note on flashing, it's like cavitation, except the process pressure stays below the vapor pressure of the fluid, and it's going to remain a vapor as we go downstream. The damage is often more severe than cavitation, but the two are closely related, and oftentimes we'll flip between cavitation and flashing when the process conditions require it. Look forward to seeing if there's something that I can help you with, someone at RE Mace can help you with. we've got some experience in doing these kind of applications and look forward to those opportunities to work with you.